Welcome everyone. Through this video, I am going to discuss how to find infinite limit with the help of definite integral. So, from definition of definite integral as a limit of sum, as a limit of sum, we know 0 to 1 fx dx, limit h tends to 0 h, summation frh, where nh equals to 1. Now we want to express it in terms of n. So as h tends to 0, n tends to infinity. So limit n tends to infinity 1 by n, summation f r by n. So in this case, for problem of limit, we express it in this form. Limit n tends to infinity 1 by n summation f of r by n. So we want to express the limit in this form. So after summation, we want to express it as a function of r by n. Then look, formula is 0 to 1 fx dx. So r by n is replaced by x. So this is our working tool. Now if it is 1 to 2n, then limit will be 0 to 2. 1 to 3n, limit will be 0 to 3, and so on. So this is our working tool. Now we consider its application. Now we consider some application. So suppose problem number 1. So if we think it as ordinary limit, then look, n square plus 1 square, n square plus 2 square, n square plus 3 square to n. We cannot write it in the term of formula. So that is why we use it formula of definite integration. So limit n tends to infinity. Now our main aim will be to express it as a summation. So look, this is 1 by n square plus 1 square. Look, there is a similarity, n square plus 2 square. So last term should be n by n square plus n square. So n by 2n square, so this is 1 by 2n formula. So then limit n tends to infinity. 1 by n. To get formula, we need 1 by n. So make it balance. 2n by n square plus 2 square, n square by n square plus n square. Now we want to express it as summation. Now look, n. So this is n into n. So first n, this is constant. Now here it is 1, it is 2, it is 3, it is n. So it is variable. We consider this as r. So n square, this is not changing. 1 square, 2 square, n square, this is changing. So we are getting summation in this form. Now look whether it is true or not. If we put r equals to 1, so 1 into n by n square plus 1 square, 2 into n, this, n into n, so it is satisfied. Now our main aim will be to express this as a function of r by n. So limit n tends to infinity. 1 by n unchanged, function of r by n. So divide by n square. So 1 plus r by n whole square. And n cancel r by n. So this is function of r by n. So from formula we can write it as 0 to 1. R by n is replaced by x. X into 1 plus x square dx. R by n is x. So now it is a problem of definite integration. So half log 1 plus x square, 0 to 1. So half log 2 and log 1 is 0. So answer is half log 2. So half log 2 is correct answer. So look, numerator is not same and denominator we cannot find the sum. So that is why ordinary process of finding limit is not applicable here. So we use process of evaluation of limit with the help of definite integration. Now problem number 2. Exactly same. So we consider again a simple problem. So limit n tends to infinity. Limit n tends to infinity. This is 1 by 1 cube plus n cube. 2 square by 2 cube plus n cube. This is 1 square. 3 square by 3 cube plus n cube. N square by n cube plus n cube. So look, there is a similarity. 1 square, 2 square, 3 square. So n square by this, n square by 2n cube. So this is 1 by 2n. Now limit n tends to infinity. Summation. So 1 cube, 2 cube, 3 cube, n cube. This is changing. So r cube, n cube, fixed. 1 square, 2 square, 3 square. So this is r square. R equals to 1 to n. Now to get formula we need here 1 by n. So limit n tends to infinity. 1 by n summation r square into n r cube plus n cube. Next, limit n tends to infinity 1 by n. To express it as a function of r by n. So divide throughout by n cube. So 1 plus r by n whole cube. This is r by n whole square. So r equals to 1 to n. So this is our main aim. 1 by n and it is function of r by n. So this is 0 to 1 x square by 1 plus x cube. So this is 1 by 3 log 1 plus x cube. 1 by 3. So 0 to 1. So answer is 1 by 3 log 2. So what is answer? 1 by 3 log 2. So interesting problem. Next, you have to recognize the problem first. So it is not given that you solve it by using definite integration. So problem number 3. So limit n tends to infinity, 1 by n sine square pi by 2n, 1 into pi by 2n, sine square 2 into pi by 2n. So sine square this, third one sine square 3 into pi by 2n, and last one sine square n into pi by 2n. So meaning remaining same, this is pi by 2. Now we want to express it in the form of summation. So this is sine square 1, 2, 3. This is changing r. Pi by 2n is fixed. R equals to 1 to n. Now it is as a function of r by n. So 0 to 1 sine square pi by 2 unchanged into x dx. Pi by 2 into x dx. So pi x by 2 as z. So dx equals to 2 by pi dz. So this is 0 to, if it is 1, pi by 2 sine square pi x by 2. So this is z, and this is 2 by pi dz. So 1 by pi outside, integration 1 minus cos 2z dz 0 to pi by 2. So 1 by pi unchanged. So this is z minus half of sine 2z. So 0 to pi by 2. So 1 by pi. So pi by 2 minus half sine pi. So sine pi is 0. 0 minus half sine 0. So answer will be sine pi is 0. So answer is pi by 4. So let us verify again. So this is pi by 2 and this is 2 by pi. This is 2 by pi. 2 by pi. So 1 by 2 sine square this. So 1 by pi. This is 1 minus cos 2z. So 1 by pi z minus sine of this. So finally what we are getting, so look, pi cancel. So this is half and this is 0. This is 0, this is 0. So half into pi by 1 by pi into pi by 2. So answer is half. So value of limit is half. So fourth one exactly same. So you try to solve, very simple. Now you consider 3 more problems, 7, 8 and 12. So consider problem number 7. So limit n tends to infinity. Look, 1 by n, it is already present. So we can write it 1 by n plus 1, 2 by n plus 2, 3 by n plus 3. This is 4n. So n plus 3n. n plus 3n. This is 4n. 1, 2, 3. So 3n by n plus 3n. So meaning is same. Now limit n tends to infinity. Listen. Express it as summation. So this is n plus 1, n plus 2, n plus 3, n is fixed. This one is changing r. 1, 2, 3, 3n. 1, 2, 3, 3n. So it is changing. So r equals to 1. If we put r equals to 1, we get first one. R equals to 2, we get second. So r equals to 3n, we get last. Now limit n tends to infinity. 1 by n, okay. So try to express it as a function of r by n. So divide by n, r by n. So 1 plus r by n. R equals to 1 to 3n. So now we have already discussed, if it is 1 to n, this is 0 to 1. 1 to 2n, 0 to 2. So 1 to 3n. So integration, this is 0 to 3. R by n is replaced by x. So x dx by 1 plus x. X dx by 1 plus x. Now integrate it. 0 to 3. 1 plus x minus 1 by 1 plus x dx. 0 to 3. 1 minus 1 plus x dx. So this is x minus log 1 plus x, 0 to 3. So 3 minus log 4. So 3 minus log 4 minus 1 minus log 1. So 2 minus log 4. So this is 2 log 2. So 2 into 1 minus log 2. So possible answer, what is? Log 4. So 2 minus log 4. So this is answer. Now, look, this is 1 to 3n. That is why integration is 0 to 3. So r by n is replaced by x. So x by 1 plus x. Now it reduces to problem of integration. Next, problem number 12. So this and these are same type. So limit n tends to infinity. Limit n tends to infinity. 1 by n is not coming. So we are taking n by na plus 0. N by na plus 1. N by na plus 2. And this is n by na plus. So na plus n into b minus a. So look, na cancel, so nb. So meaning remaining same. So n, this is balanced by this. Now we want to express it in terms of summation. So n, this is fixed. So na fixed. 0, 1, 2. So this is changing. So this is r. So what is r? R equals to 0 to b minus a into n. 0 to b minus a into n. Now try to express it as a function of r by n. So dividing it by n, a plus r by n. So this is 0 to b minus a. So if it is 1n, this is 0 to 1, 2n, 0 to 2. So b minus a multiplied by n. So dx by a plus x. So this is log a plus x, b minus a to 0. So log a plus b minus a. So this is log b. If it is 0, then log a. So log b by a. So this is log b by a. So answer is log b by a. So our main aim to express it in terms of summation. So look at the pattern. This is 1. So na plus 1, na plus 2. So this is na plus 0. So to make meaning same, na plus n into b minus. Now problem number 8. So limit n tends to infinity. 1 by n is not coming. So this one we can write at 4n square minus 0 square, 1 by 2n, and it is balanced by n. N by 4n square minus 1 square, n by 4n square minus 2 square, n by, so 4n square minus n minus 1 whole square. Second term 1 square, third term 2 square, so nth term n minus 1 whole square. Now 4n square minus n square minus 2n minus 2n. So meaning remaining same. Now express it in terms of summation. N, this is not changing. 4n square not changing, this is r square. So r equals to 0 to n minus 1. So if it is 1 to n, formula is 0 to 1. 0 to n minus 1, same formula. So try to express it as a function of r by n. So divide by n. So this is 1, and within root over you have to divide by n square. So r by n whole square. So this is our main aim. So from definition, this is 0 to 1 dx by 4 minus x square. So this is sine inverse x by 2, 0 to 1. So sine inverse half minus sine inverse 0. So half is pi by 6. So pi by 6 is possible answer. So look at this step. 2n. So 4n square minus 0 square. 4n square. So look the pattern. Second, third. So this is 4n square, n minus 1 whole square. So from the terms, so pattern of terms, we have to write the summation. Next we consider second type of problems. Now we consider second type of problems. So problem number 4. 4a. This is problem number 11. They are of same type. So consider problem number 4. So limit n tends to infinity. So write a equals to factorial n by n to the power n, total 1 by n. So factorial n is 1, 2, 3 dot dot n. This is n, n times. Power is 1 by n. So this is 1 by n, 2 by n, 3 by n by n. Power is 1 by n. Now we know formula for summation. So this is given in product form. That is why we have to take log on both sides. So log a equals to 1 by n, log 1 by n, log 2 by n, log n by n. So if it is given in product form, we have to take log. So 1 by n, then summation log n unchanged. This is r by n. R equals to 1 to n. Now we want to express it in terms of formula. That is why we have to take limit n tends to infinity on both sides. So limit n tends to infinity 1 by n summation log r by n. So this is 0 to 1 log x dx. So r by n is this. So integrating by parts. So limit n tends to infinity log a. So log a, log x. By parts, if we integrate it, this is x log x minus x. So log x unchanged, integration of 1 is x. So 1 by x into x cancel. So this is 0 to 1. So 1 log 1 minus 1, 0 minus 0. So finally we are getting minus 1. Now from convergent property, log can be taken outside the limit. So limit n tends to infinity a equals to minus 1. So base is e. So if we omit logarithm, so limit, this implies limit n tends to infinity capital A equals to e to the power minus 1. So put value of a. So what is a? A is factorial n by n to the power n required limit. So this is 1 by e. So what is value of the limit? Value of the limit is 1 by e. So for b, this is exactly same. So we consider 11. So look this step. This is factorial. This is given in product form. Formula is applicable when it is in summation. So that is why we are taking log on both sides. Now, problem number 11. Limit n tends to infinity. 1 by n is present. Log 2n. So what is 2n? 1, 2, 3 factorial 2n. n plus 1, n plus 2 dot dot n plus n. And factorial n. So 1, 2, 3 dot dot n. This is factorial n. This is n to the power n. So up to n is cancel out. Now it is of the previous one, exactly same. So log n plus 1 by n plus 2 by n plus n by n. So limit n tends to infinity. 1 by n log 1 plus 1 by n, 1 plus 2 by n, 1 plus n by n. So limit n tends to infinity. Product of log, this is sum of log. Log 1 plus 1 by n, log 1 plus 2 by n, log 1 plus n by n. So log is already given, otherwise we have to take log on both sides. Now try to express it in terms of summation. Log 1 unchanged, so r by n, r equals to 1 to n, 1, 1, 1, so only 1, 2, so this is changing. So this is 0 to 1, log 1 plus x dx. So 0 to 1, log 1 plus x dx. Now integrate it by parts. So now it reduces to the problem of integration. Log 1 plus x. X is replaced by 1 plus x. So 1 plus x, log 1 plus x. X log x minus x. So this is 0 to 1. Log x, x log x. X is replaced by 1 plus x. Now put x equals to 1. So 2 log 2 minus 2. 2 into log 2 minus 2 minus 1 into log 1 minus 1. So 2 log 2 minus 1. So this is log 4 minus log e. So log 4 by e. 4 by e. Answer is log 4 by e. So we are not taking log, it is given in terms of logarithm. So answer is this. But if this log is not present, then we have to take log on both sides. Now 9, 10, exactly same. Suppose problem number 10. Here they are given in product form. So suppose this equals to A. So if it is given in terms of A, we have to take log on both sides. So I think this is 1 by n. And total is 1 by n. So take log on both sides. Log A equals to 1 by n log. This is obviously 1 by n. Log 1 plus 1 by n square, 1 plus 2 square by n square, 1 plus n square by n square. So 1 by n, sum of log. Log 1 plus 1 by n square. Log 1 plus 2 square by n square. Log 1 plus n square by n square. Now express it in terms of sum. Log 1 plus r square by n square. R equals to 1 to n. Now to get formula, we have to take limit on both sides as n tends to infinity. Limit n tends to infinity log a. limit n tends to infinity 1 by n summation log 1 plus r square by n square. So this is integration 0 to 1 log 1 plus x square dx. Now, so most interesting, so log outside limit n tends to infinity capital A. So by parts, log 1 plus x square into x minus derivative 1 plus x square into 2x, and this is again x dx. So this is 0 to 1. So x log 1 plus x square 0 to 1 minus 2 outside x square by 1 plus x square dx. So if we put 1, so 1 into log 2, and if we put 0, this is 0. So 1 into log 2. 2 into 0 to 1, 1 plus x square minus 1. So log 2 minus 2, this is 1 minus 1 plus x square dx. So log 2 minus 2 plus 2 tan inverse x. Log 2 minus 2 x minus tan inverse x. So this is 0 to 1. So finally, log 2 unchanged, 2 into, if we put 1, so 1 minus tan inverse 1 minus 0 minus tan inverse 0. So finally, log 2 plus 2 into pi by 4. So minus minus a plus, this is pi by 4 minus 2. So pi by 2 plus log 2 minus 2. So what is A? Limit n tends to infinity capital A equals to e to the power pi by 2 plus log 2 minus 2. So this is possible answer. So interesting problem. So today through this video I have solved some important problems of limit with the help of definite integration. So these problems, this type of problem are important for competitive exam. So you solve rest of the problem. Thank you for today.